Okay, so what we have for this problem is I want you to just imagine a box on a table, and then there's a force causing this box to move, right? And then the initial velocity of the box is 0. So look, the longer this force acts for, the longer it acts for, the more the momentum will change, right? So one of the equations we've been talking about is change of momentum equals F net multiplied by time. The longer the force acts for, the greater the change of the momentum, right? Now, first question here. The impulse of the force. So what do they mean by impulse? Impulse, they want what? Momentum. Change of momentum. So if you have a force versus time graph, the area under the graph is going to be what? How do you calculate area? You go base multiplied by height. If you multiply force by time together, look right here. Force multiplied by time gives what? The change of momentum. So the way you answer the first question, so let me revert this back, clean it up. The way you answer the first question for the impulse is you basically take the area under the graph. So you want to do two things. Break this into a square or a rectangle and a triangle. So what's the area of this rectangle? 6. And then, yeah, it'd be kilogram meter per second. The area of the triangle is 2. So what's the total area? 8 kilogram meter per second. Or 8 spaldos, thanks. 8 spaldos. Okay, so that's the answer to the first question. The change of momentum is 8 kilogram meter per second. Okay, B. The final velocity of the object if it's initially at rest. So now you can go, well, what's another way to calculate change of momentum? You can go momentum final, which would be MVF, minus momentum initial, which would be MV initial. If it starts at rest, what goes away? MV initial goes away, so then you're left with this. So then you can go, okay, V final must be the change of momentum over the mass.
Please excuse the interruption. All girls water polo, please release at 1:15 today. All girls water polo are to be released at 1:15 today. Thank you.
You're welcome. Okay, so for that, comes out as 5.3 meters per second. And then the last question, the final velocity of the object if it's initially moving with a velocity of -2. So A, what does that mean? So it's like, look, here's your object you can think of. To the right is plus, to the left is minus. The force is positive, pointing to the right. But what does it mean if the initial velocity is negative? If the initial velocity is negative, that means that it's initially moving against the force, right? The velocity is to the left, but the force is to the right. So how do you deal with that? Well, change of momentum equals MVF minus MV initial. We just got to make sure that we make that V initial what? Negative. -2. Okay, so we're looking for V final. V final is going to be change of momentum plus MV initial over M. So that's going to be 8, right? The change of momentum is 8, plus the mass is 1.5, and then make sure you make the velocity negative here. -2 over 1.5. So what's that going to be? So it's going to be 8 minus 3, so 5 over 1.5. 3.3. So is that moving to the right or to the left at the end of the problem? To the right. Positive means to the right. For the square here. So look, the base was 3. The height is 2. So 3 times 2 is 6.